Hi. Now let us talk about the friction force for this example. We were talking about this example on the classroom. If we have uh, the board with an iron surface and we have the eraser, this is the blackboard. This is an eraser and we have a magnet inside this eraser which keep it stick to the board. In general, without this magnet, the eraser will fall down. But what is the purpose of this magnet? Now we will see that if the mass of the eraser is 0.08 kilograms and the friction coefficient between the surface of the eraser and the surface of the blackboard is 0.1 unitless. We need to find the magnetic force between the two objects. Now let us look at the free body diagram. We have the magnetic force to the right inside the board, and we have the normal force, we have the weight downward, and we have the friction force now upward, and this friction force is static friction force. And the maximum static friction force is equal to mu s multiplied by the normal force acting on that object. Now, at equilibrium, we have total F in x direction are 0 and total F in y direction are zeros. So total F in x direction is equal to 0, which are F the magnet minus the normal force. F in y direction, which are the friction force upward and the weight downward. Okay? From the first one, and from x direction, we have the normal force. Just move this normal force with the negative sign to the opposite side. This will give us that the force from the magnet is equal to the normal force. N equal Fm. We need Fm, which is equal now to N. We will use it in the next equation, which is the y component forces. The y component, we have the friction force upward and the weight downward. The weight is mg. We have m, which is 0.08. Mu s is given. And now, by ordering the equation, we have mu s multiplied by n is equal to mg. Now, n is equal, just divide over mu s. N is equal to mg over mu s. This is equal to F magnet, as we see. Now, the weight, which is mg, is equal to m multiplied by g. And the weight is equal to 0.784 newtons. Okay, this is the weight, which is mg over mu s, mu s 0.1. This will give us that F, the magnetic force, is equal to 7.84 newtons. I compute the weight and let you look at the weight and the normal force, which is the magnetic force, and compare it with the weight. It is very big than the weight. F normal is larger than the weight. The weight is downward and the normal force is perpendicular. To see that, if we need to catch any object with a wall like this, we need to put more force than its weight. We need to put bigger force. It is about 10 times, as you see from here. You need to put 10 forces. Let us look here. if we have this, if we have the weight is just one arrow downward, then we need to put 10 arrows. This is the weight, this is the force. We have one arrow downward, we have 10 arrows perpendicular to keep this object from falling. This is an example on friction force.